Both of them?
This is lesson 3.4. Today we're going to solve some equations. But first, we have a warm-up, 2 problems. Classic review problems from the last lesson. 1 expanding and 1 condensing. I would condense first. Oh wait, what are you talking about?
Distribute the exponent into all of them since it's not adding or subtracting.
Yes. Like you can bring this down, is what you're saying, and then it would go to all of them when you break it up. Yes, that's right. That is the correct thinking. Got it.
I think I got it. No promises.
Is that 4 on the top one? Is that like saying it's the 4th root or just like 4?
Just 4.
No, just 4 times. Yep. 4 times the square root of y. Okay, I'm gonna start doing the problem here while you guys are looking.
Calculation now.
Usually we bring down the exponents last, but in this case, that power of 3 is with all of those terms inside the log, so I kind of brought it down first, and then when I break it up, I would probably use like a bracket here. Okay, I'm going to do this. I'm going to do this in 1 step, so we would have 4 plus square root of y minus cube root of x. I'll use my colors here. Plus, because we have a product. Minus, because we have a quotient. Okay. Then I'd rewrite the radicals as powers. And bring those down as well. Okay, if you got this far, log base 2 of 4 is what? 2. 2 to what power gives me 4? We can simplify that. 2 to what power gives me 4? That's just 2. Okay, sometimes those are tricky to catch when you get stuck in doing all these ones with the variables. And then I'd finish by distributing 3 through. So my final answer should be 6 plus 3 halves log base 2y minus 1 log base 2x. Did we get there?
Yes.
Yeah, it's right there.
If not, don't worry, you have plenty to practice on your homework.
Oh,
Yay, thank you.
Lord.
Practice makes I care
I
about
boost the confidence.
care about your learning.
Sure.
Okay, there's a good expanding one. Condense, I'll give you a couple minutes to try this one if you haven't already. Going backwards, now I want to put this all together in one big happy log family. So your final answer should only have one log. So you're condensing this one. If I were you, I would condense this first inside the brackets. I would condense that inside first before applying that 1/2 piece to this.
We got this.
Okay, so I kind of put those powers back first. And as I mentioned, I'd condense this inside. So since I'm adding these, we would multiply. You don't actually have to do the multiplication. You just write it like that. Remember that square would only go to the x minus 1 because it was in that 2 was in front of that log.
You need to apply that in the-
Nope. This should be a. Then we can put this 1/2 power in this log, and let's just rewrite it as a radical. So that'd be the square root of all that. I feel like we did this problem yesterday. It was.
There's a square root not cancel out with that square.
You could do. I mean, not that this one would stay under. The x plus 1 would stay under.
Yeah.
You could do that and like bring out x minus 1 if you wanted to. You just don't have to do that much simplifying. But like you technically could do this.
That's what I did yesterday.
That would come out, but you'd still have this left under. You could do that. You just don't have to. I do have to condense this further though. Well, free homework problem if you haven't done your homework yet. I'm adding these so I'd multiply. Is this the exact same one we did?
Yeah.
What the? Why did I do that?
So what?
Language.
I just said what the? Why did I do
Finish
that?
sentence.
What the heck?
That's what I thought you were gonna say.
I don't know why I did that. Sorry. I apologize for my lack of creativity.
Is that a mistake?
Number trucker, dude.
I'll put that on my notes. Okay. So today, solving equations, which is fun. Students are usually like pretty strong at solving equations. It's just a little boring because it's just example after example after example. There's no fun like graphs to look at or anything like that. So it's just practicing a bunch of examples. Okay, here's your little exploration, as I call it. These are technically, all 4 of these are technically examples of exponential equations because where is my variable? In the exponent. Yep. Okay, now these ones are all ones you could probably figure out like in your head. Like 5 to what power, give me 25. So I'm gonna let you try these first 4 before I teach you how to do it. See if you can figure it out. Nice. That's what I was looking for. You can use your calculator for number 4 if you want.
Wow.
Sorry. Sorry if that was unclear. Wait, how do you do that under?
Math.
Nice, good. Yes. Wow, impressive.
There goes my goal. My goal is to be a disappointment.
Good job. Impressive. Nice. Yep, that's what I was looking for. Good. Oh, Jesus. All right, so number 1 is obviously 2. 5 to the power of 2 gives me 25. 2 to what power gives me the square root of 2?
1/2.
1/2.
1/2.
This one, couple ways. I kind of showed you that you could like rewrite the same side of the equation with like bases. If you can do that, like rewrite this, 8 is 2 cubed. And then we use like kind of common sense that if we have the same base, then the powers obviously have to be the same, but I bet a lot of you could figure out that 2 to the 3rd, which would be 8 minus 5, would give me 8. Okay. So a lot of this thinking sounds like something we've been working on. 5 to what power gives me 25, 2 to what power gives me the square root of 2. So here's how I saw some people when I was going around saying, nice, yeah, evaluate this. They did log base 2 of 10. Because that's asking you 2 to what power give you 10, right? Or if I asked you to rewrite this equation in log form, you would do log base what? 2 of 10 equals what? Equals x. That could be how we figure out what x is. So I type that in your calculator, log base 2 of 10, either using that tool that says math, log base. Okay, we'll go over that. Or another way you could type this in your calculator, remember that what we talked about, that change of base formula, you could do log of 10 divided by log of 2, or you could even do the natural log of 10 divided by the natural log of 2. Those would all give you the same answer of about 3.3219. Or 9, Okay, nice. So when it's not something we can just do in our head, we use logarithms to solve exponential equations. Similar to the idea of, I know this is easy, but this equation, you guys could solve this in your head, or you can use inverse operations, right? What's going on between the 2 and the x? Multiplication. What's the inverse operation multiplication? Division. We could divide both sides, like take off those layers around x. What's the inverse of exponential functions? No.
Square.
Logs, right? When we graphed them, the inverse of exponential functions was log functions. Logs undo exponents. So similar idea when we're solving equations. Logs will allow us to take off layers around our variable when we have the variable up in the exponent. Okay, so this is basically a really wordy way of saying if you can rewrite, if you have an exponential equation, we'll start with exponential equations, then we'll move into log equations. If you can write them with the same base, then do so and just set the powers equal to each other. Okay, that's the easiest way. They call that one-to-one property. Same with logs. If you can't, we're going to use the inverse property. Actually, this is the one we're going to do. We're going to take the log base, whatever base is on your exponential equation, of both sides, and that will get rid of that base of a and allow us to solve for x because they're inverse properties. Okay, we've done something like this where I've given you like, and I prefaced it with, this is really asking you 3 to what power gives you 3 to the x. So it's obviously just x. And I told you, hey, these are inverse operations of each other, so this undoes that, and we'd just be left with x. So So this is going to help us solve equations when our variable's up in the power spot. It kind of allows you to bring the variable, like I like to say, like to the ground. Okay, when it's up there in the exponent spot, logarithms allow us to bring it to the ground and solve. And I always think of solving equations as you're just taking off the layers around x. It's one big onion, not because they make you want to cry, but because they have layers. That's my solving. That's my solving equations joke that I get to use a lot of times because we solve a lot of equations, right? Okay. So first we're gonna do the one with that what they call the one-to-one property, but I would be able to write each side with the same base. Okay, so this would be essentially the easiest way to solve something like this. In this exponential equation, my base is 2, right? So I see 16, I know it's 1/16, but I see 16, I'm like, hey, I could rewrite the number 16 with a base of 2, that's 2 to the 4th. So in this case, I'd kind of use that one-to-one property, and you guys have solved ones like this. There were some on your quiz. 1/16 is 2 to the negative 4th. So if you can do that, you don't really need logarithms to solve this. You just set the powers equal to each other and solve for x. Oh, that's plus 5. Sorry. That's going to make my answer negative 9. Okay, that's right. X is negative 3. Now, because in exponential equations, think of what exponential functions look like. Because our domain is always all reals, you don't really have to go back and make sure that it like fits in our domain. Okay, because we can take the exponent of any number, positive, negatives, fractions, whatever. Obviously, you could check your answer just like any equation by plugging it back in. 3 times negative 3 is negative 9, plus 5, 2 to the negative 4th is 1/16, right? So when you have exponential equations, and the reason why I'm prefacing this is because when we go to solve log equations, those have restricted domains, okay? But with exponential, our domain is all reals. You don't have to worry about that. All right, I have 101/10. What number could I rewrite with a common like base? 10, right? I could rewrite 100 as 10 squared. So I have 10 squared to the power of x. And I could rewrite 1/10 as 10 to the negative first. All right. Power to a power. What operation do I do with the exponents? Multiply. 2 times x is 2x. Here I'm going to multiply as well. I'm going to have to distribute that. It's going to become negative x plus 3. So again, I don't really need logarithms to solve this. I have the same base, so obviously my powers have to be the same. And we get 1. Okay. We could use logarithms to solve this, so once we go over some of those, I'll come back and show you how you could use logs. But they're saying here, hey, if you can do this, go ahead, just set the powers equal to each other. I think that's probably the easiest, but you could also use logs. Okay, let's get into some ones that are more log involved. Okay, first question for you guys. Well, obviously the directions say exponential equation, but we can tell in all of these problems, where's my variable? In the exponent, in the power spot, right? Okay, that's what makes this an exponential equation. Next question for you. Can I multiply this 8 and the 10 together? No. Good. So instead of that, think of how could I get rid of this timesing by 8. Here's my variable. So I have a couple layers around my variable. It's being times by 3. It's being raised to a power with a base of 10, and it's being times by 8. So instead, to get rid of that 8, we're just going to divide both sides by 8. We're just picturing trying to take off the layers around my variable. Okay, that obviously just leave me with 10 to the power of 3x equals, we'll simplify this to 3 halves. All right, now notice, I don't have 10 times 3x here. I can't divide off that 10. I have 10 to the power of 3x. And here's an example of I couldn't rewrite 3/2 with a base of 10, right? So we have to use logs to solve it. So you could picture this and like rewrite it in log form, but we're thinking inverse operations. What I'm going to do to get rid of that base of 10, to take off that layer, is I'm going to take log base 10 of both sides. I picked base 10 because that's my base in this exponential equation. So I can take log base 10, remember that's my common log, so I don't have to write a base, of both sides. And this is an equation, so we can do that as long as we do it to both sides. So that would undo that base 10. Those are inverse operations. And that would leave me with just 3x. And that kind of brings that power on the ground. And over here, I'm just going to leave this as the log of 3/2. We'll have to evaluate what that is in a second. Okay. Again, I picked the common log because I had base 10 over there. Only one layer left to take off my variable. That'd be divided by 3. Get rid of that. So as an exact answer, we could say that's the log of 3/2. All of that's being divided by 3, or you could times it by 1/3. And we're going to get an approximation here in a second. Once I can pull up my grapher. This one's a common log, so I can use that common log button. That's kind of nice. I'm going to take the log of 3/2, close that argument. You can either hit enter, or we want to divide this whole thing by 3. So we get about, we'll round to 4 decimal places, 0.0586, dot, dot, dot. You don't even have to round up. Just take the 4 decimal places. That's what you do in calculus, so let's get in good habits. Okay, so we get about 0.0586, dot, dot, dot. Now you could check this by leaving that nice long answer in your calculator, and I'm going to plug it back into my equation. So I'm going to times it by 3. I'm going to do 10 to the power of that number. So remember, you can hit like second, the negative sign, it'll feed that whole answer. 10 to the power of that, times it by 8, should get 12. Nice. Yes,
His calculator is broken.
I don't know how.
I think it's user error.
Mine works just fine.
Well, usually.
What's wrong with yours?
So like it comes up way different when I do log base. Like it just doesn't work.
Okay,
I don't know.
I'll take a look at it. Just don't let me forget. Just not at this instant. I'll look at it. I bet you're just typing it in wrong.
Well, I'm going to math and I'm going to log base, but the log base is coming up differently.
Yeah, so
It's
we're
coming
like,
up with a parenthesis. It doesn't even come up with.
oh, it doesn't let you type in a base?
Oh, yeah, it looks different.
You might have the older version? Do you? I don't know. Where'd you get that calculator?
You.
Oh, then it should be updated then.
Some is just probably like a setting.
I can always update it too. Yeah, we'll figure it out. Okay, so really quick, I just want to go back to this and show you how you could have like taken off the layers of log. We technically could have done this. Okay, let's do this example because this is another log base 10. I could have taken the log of both sides, and that would just undo those, and you'd be left with the powers, right? So you technically could do that. Here, what's my base on this exponential equation? 2. So we'd have to take the log base 2 of both sides to get rid of that. Okay. All right, let's do another one. Ooh, a few more layers.
How's that going?
What would be the first thing you'd get rid of?
Mine's 4.
The 4, right? Then what would you get rid of?
2.
2, good. Do not times it to that 3. Get rid of it using inverse operations with division. Okay, now I'm stuck because I can't rewrite 6 with the base of 3, so I have to use logs. I'm going to take log base what of both sides?
3.
3. Good, because that's my base on the exponential equation. That gets rid of that base of 3. We're left with 2x minus 5 equals log base 3 of 6. What would you do next? Add 5. Now, that does not become log base 5 of 11. No. This is the one you're taking the log of. If you want to add parentheses on it, you can. And I can't just like add the insides. Okay, this one doesn't even have a logarithm, so I can't combine them. And then I would divide that by 2. So here's my exact answer. Log base 5 of 6. Oh, log base 3. Where did I get 5? Log base 3. Sorry. Log base 3 of 6 minus 5 divided by 2 or times a half.
Why is it minus 5? Why is it minus 5?
Plus 5. Sorry.
Oh,
You're not making any falling apart
I
here.
am.
making sure paper
Easier
takes
to
that.
Okay.
About a free day today.
So remember to do log base 3 of 6. You can go math.
Alpha A.
Alpha A, log base 3 of 6. Outside the argument, add 5. Divide that whole thing by 2.
Nope. We do that.
You can also, you could do this too. If you want to do that, you can like use your common, you can do the change your base. I don't want to confuse you, but this like worked for Max since his is not working.
Yeah.
You can do the log of the top divided by the log of the bottom or natural log. Add 5, divide by 2, and you get the same answer.
We got that.
This is what people with non-fancy calculators have to do.
Yeah, Max.
Yeah, please.
Okay, let's write down that decimal. 3.3154 ... Just take the take the 4 digits. Okay. Ooh,
Ooh, he's
an E.
Man.
All right.
We do a log of E. Is that a thing?
Well, what's log base E?
Yeah, I don't know.
You're gonna use natural. Exactly. What would be the first layer we would take off? 7. Next layer. 4. You gotta divide by 4. And I'm here, and I definitely can't rewrite the number 5 using a base of E. So I'm gonna take the log base E of both sides, which is the natural log. That we'll get rid of that base E, and we're just left with negative 0.3x equals the natural log of 5. So we just have to divide that by negative 0.3. So here's the exact answer, technically. I would just do in my calculator the natural log of 5 divided by negative 0.3. There's our approximation. I will probably only check, like on a quiz or a test, I'll probably only check like your decimal answer, is what I'm thinking. It's way easier, guys, to like wait to the last step to type it in, because if you like type in natural log of 5 and then you like round that and then you divide that by negative 0.3, then your numbers get off. So just like wait till the last step to kind of type it all in. But I'll probably only like check and make sure you have this number written. Okay. This next one is a little bit more challenging because I have exponents on both sides and I have two different bases. So I'm like, do I take the log base 5 of both sides or do I take the log base 4/3 of both sides? The answer is neither. You have two options. You can do the common log of both sides or the natural log. I usually just use natural logs because I think it's just a little easier. So here's what we can do, and here's where our last lesson comes into play. We can take the natural log of both sides. That's fine to do as long as you do it to both sides. So if this happens, it doesn't undo my bases. But what we can do is use the power property that this can come out in front. Yep. And so can this. So I have x, 1 minus x, times the natural log of 4/3 and then I have x times the natural log of 5. Okay. So this one's a little weird. I'm going to have to like distribute this. This is just a number. Distribute this to the x and to the 1. So I'm going to distribute it to the 1 first. Natural log of 4/3 times 1 is just the natural log of 4/3. And I get minus x natural log of 4/3 equals x natural log of 5. Okay, everybody with me?
Yes.
You add
What about the x and the 4/3? Why was that number?
What?
Think of this, so you're doing this times this, and I'm just writing the negative x like in front.
Okay.
Yep, this is really just a number. So I'm just writing this as negative x times the natural log of 4/3 to keep it exact. All right, what we're going to do is we're going to move this to the other side and like factor out an x. Okay, so I have x natural log of 5. Think of this all as one term, plus x natural log of 4/3. Oh, it's a little more complicated. So basically, you want to get like all your x's on one side so that you can factor out an x, which would leave me with the natural log of 5 plus the natural log of 4/3. We're almost done.
Can't scroll my paper down the queue.
Yeah, right.
You ran out of room to write?
Yeah.
Well, write smaller next time.
Yeah, well,
That's good.
Thanks, like,
Okay, remember guys, this is really just a number, right?
Yep.
This is really just a number. You can almost think of this as like you have a 5x plus a 4/3 x. You factor out an x. You probably wouldn't do that. You'd add more to it. Whatever. Think of this as a number. So how would I solve for x? I would just divide both sides by that whole number. Divide both sides by this. You're like, I was having fun until now. And that would get rid of that whole number. So our exact answer would be this. The natural log of 5 plus the natural log of 4/3 in the denominator. Natural log of 4/3, those do not cancel. That'd be my exact answer. Yeah, sorry, I didn't give you a lot of room to write, did I? Maybe. Alright. Let's type this bad boy in our calculator.
Yeah, that's
0.1516.
But you guys survived. Make sure you wrap the denominator in parentheses. We got a natural log of 5, close, plus the natural log of 4/3. Close, close. That's what you should get.
Hoorah.
no, not hoorah.
Fair enough.
That doesn't come up a whole lot where you have to do
What
it.
genius
Yeah.
is even able to think, oh yeah, I just gonna how I just give it some other 0.15.
Hey, listen, you just like,
Yeah, how did they come up with these numbers?
Right?
maybe they guessed and just
I'm generally
accidentally fell on it.
curious.
Whatever everything.
What is
That is actually a really
Log.
good question
Numbers.
because nothing in like life seems like it's going to have a log.
And
in
There
why
is
that?
some
Unless you're doing some
there is some
crazy
type of
engineer.
scale. I feel like I don't want to guess because I'm probably gonna be wrong. I think it's like when you measure. What's a Richter scale? Is that when you measure tornadoes?
That's
Earthquakes? Earthquakes say this way. I think they use a logarithmic scale.
So like, I'm not gonna be
Well, because EM5
But
is like.
That could be wrong. Maybe what is the one that measures the intensity of like tornadoes? What's that one?
I still don't think I used that.
I don't even know if
Okay,
they do
so,
that.
If that's not a thing.
Storm chaser. I think really what they do is they see how much damage happens and then that's how they grade it.
Okay.
Yeah.
I don't
use their
know.
eyes.
Or maybe is
Tornado size.
hurricane different? I don't know. Don't they measure the intensity of hurricanes?
They just measure the wind speed.
Wind speed.
There's a
Okay.
certain name for it.
I'm thinking it's. I'll have to look it up. I can't quite remember. Okay. I have a couple for you guys to try.
bullshit.
Jeez,
This guy.
these ones aren't bad.
They're what?
These are not bad.
How about that?
You guys try these, and then we'll do the next
Oh,
2 examples, and then we'll stop at exploration.
You didn't hear that.
Let me see. Let me quick figure out that.
Oh, this country. I'm gonna show you this
Oh yeah.
special thing. Alright, so we go second.
First one's pretty easy.
No.
No, zero.
You don't know. Just
So,
give up.
I don't know.
Yeah, too easy.
Oh, okay. So I think what
If
you
I
have to
did this
do.
right,
I think you have to do. So you want to do.
No, it's,
Zero.
it's fine.
X equals the natural log of
Just
1.
get good.
Yeah,
Yeah.
good.
So I think you.
Except for like graphical
Carter, is
behavior
number one,
is
you get X equals L and 1.
yeah, 0.
Okay, I think I might have to update this.
You mean 8. No one is
Ooh,
16
you're
divided by
outdated.
8.
I will trade you calculators.
uh-huh.
You can take
I
mine.
would
Yeah.
like 2 something power. 2, 3 halves maybe.
My favorite two. Second.
Heavyweight.
Okay.
Heavyweight.
Yes, the Richter scale is a base 10 logarithmic scale.
Oh my gosh.
Oh, yeah.
Who just thinks that's fun? I just don't know.
So what is that? That's mathematic 2.
What did you get for 2?
2 what power would you need?
Like the actual answer?
There is a tornado strength scale,
I need it.
which
The
gives a
F
rating
system.
You have
given by
like
based on
log
wind
base 2
speed
of
and
8/3.
severity of the damage.
Yeah.
So
Really?
That's funny.
add 1.
Yes.
It's not a logarithmic scale.
Fine, I'll try that.
Can you try
Divide by
that?
3.
It's what it equals.
See what you get. For the final answer to that, I'm grabbing calculators
I
then.
got 1.2.
Okay.
0.75.
1.20.
Oh,
7.
Oh, was someone knocking? Big it, ding dong, bitch.
And now what do I do?
oh, it's Jackson.
Oh.
He gets up there.
You guys don't really need logs to solve this one. E to what power would give me 1?
It's definitely
Zero.
0. If you did take the natural log of both sides, careful, the natural log of 1 isn't 1. It's 0.
I literally got that one wrong.
Yeah, it is.
Oh, you see. It's, no, it's not.
Why?
Yeah, no.
That's 7 divided by
I will enter the
6.
first. Just zero.
What do you got?
The natural log of 1 is 0.
Yeah, so if we just said ln 1, would that be right?
No.
That's the exact answer, but you should put 0 too.
Yeah.
Buddy.
Okay.
Well, let's see what the calculator. ln 1 equals 0.
Let's see how we did on this one. We got 8/3.
I know it's crazy.
Log base what of both sides?
2.
Yes.
Good job. You're just so smart.
Right?
Looking long.
Intellectual conversations that we have are just top tier.
Alright, so then you take that number, log base 2 of 8/3. You'll add 1 to it and you'll divide by 3.
Oh my god.
It's just brain impractical because it's not.
8/3 2 base log.
Let it snow, let it snow.
Alright, anyone
Jackson.
want to give
Just
out
glad
their
it's not sticky.
decimal?
1.2075.
Oh, I got something else.
I got
Oh,
0.8050.
Saucy.
You told me what it equaled,
I'm
Carter.
gonna start calling you Jess.
Did you do that
You guys
one
are not
yourself?
done. We're not done. We're going to do the next at least one.
What?
Oh my
Oh,
gosh.
we don't have time.
I can't start
Let's do it
it.
ourselves.
Okay.
You're gonna help me figure out my calculator.
Yeah, help them.
Alright.
Yeah.
Oh, we do not have time.
This one.
I already put my head.
It's dependent comment, like, or like, what I multiply this by 6, multiply this by
Anyways.
2 and get 6, and make them all the same base.
No, but I like your idea. But no.
Not.
This is kind of like in quadratic form almost. Doesn't it kind of look like a trinomial?
Yeah.
Can we go over that last one again?
Let me rewrite this.
Could we use quadratic form?
Oh, wait.
No, but I like your thinking.
What's going on here?
All right. So 3 to the 2x, I could rewrite it like this, right? Because power to a power just multiply, kind of like using exponent property backwards. And so this would factor
No.
into 3 to the x.
Why do we keep factoring?
Just gonna write this on quick.
We'll just factor it and then we'll stop. So 2 numbers that multiply to -2 and add to 1 would be -1 and +2. So it's almost kind of like in this quadratic form. Let me show you here, where you have like a 1 right here, 1 times 3x, 3 to the x, 1 times 3 to the x, -2. Kind of see it
Yeah.
in that quadratic form? Okay, we'll stop there. We'll pick that up on
I
Monday.
got those numbers.
Uh-huh.
It wasn't me, it was mine.
Well, hey,